Are you looking for a solution to protect your web apps against the most business-critical security vulnerabilities? Unleash the power of automated ethical hacker knowledge with Detectify for continuous coverage and relevant security vulnerability findings. Upgrade your web app security with speed and scale and start a 2-week free trial at securityweekly.com/Detectify. Go hack yourself. Security teams need visibility into Linux systems to detect and investigate incidents and protect against unwanted activity. Operations teams are not down with downtime, and with revenue tied to uptime, ops priorities are enterprise priorities. Which is a higher priority? Why not both? Capsulate provides flexible, production-ready infrastructure protection for Linux systems, all without a kernel module. With ops-friendly production security, Capsulate delivers monitoring, detection, and response without adding operational risk or cost. Visit securityweekly.com/Capsulate today to request a demo. When it comes to web app and API security, the choice is simple. You can choose Fastly's security solution that teams will actually use in full blocking mode, just like 90% of their customers. Or you can stick with costly options that you probably just turn on. You can get Fastly's all-in-one platform that protects apps everywhere they live, however they're built. Or departments can agree to disagree. You can go to securityweekly.com/Fastly to learn more. Or you can just wish you had.
Welcome back to Application Security Weekly. I'm your host, Mike Shima, joined as always by John Kinsella. Do you have a specific guest or topic that you want us to cover on one of the shows? Perhaps you want some more Halloween references, who knows? Submit your suggestions for guests by completing the form at securityweekly.com/guests. We do review suggestions monthly and will reach out to you once reviewed. And this, Mr. John Kinsella, brings us to news of the week. As I mentioned with Doug, I didn't even know it was National Supply Chain Integrity Month, so that was cool to see. And I think we have some articles that are sort of related to supply chain integrity, if not just some problems in the application space, so that's a good thing. But maybe we should lead off with an interesting article that you found, which is sort of possibly presents an existential crisis for us, which the theme of was, should security and developers, DevOps, collaborate or not? So let me throw it over to you to maybe give us a little bit of an intro into this article, and then let's see if we should stop early.
Sure. Hot potato catch. So yeah, it is a security supply chain month. I think those guys are better at the security supply chain than they are marketing of the month, so we got to help them out
perhaps
here.
So.
Yeah, so this hopped on my radar. I don't know how, but it's a VC. He's over at Dell Technologies Capital, and his post, and I think he's trying to play devil's advocate himself, which is what I'm going to do here as well. But his thesis they're putting across in this post is: look, security people are a cost center. Developers are making a product which actually is going to generate revenue. These two folks have completely different goals in life. They are never meant to play together. Stop trying to do DevSecOps. Vendors should stop trying to build DevSecOps products. Y'all are crazy. Can we just keep doing things the way we have been? So that's sort of it. I mean, he goes through some talks around and some sort of sets up, and VCs are good at pretty much arguing any side of the coin they want to. My own. So I think I brought this here because I think it's worth us having a conversation about it. And yeah, look from outside the devil's advocate type thing. Myself personally, I think this particular train of thought is about 5 years outdated. But that said, okay, let's step back and think through, especially after some of the conversations we've had over the last month around, embedding either security into the dev side or dev into the security side. Are we wasting our time and we're trying to get the cats to play nicely with the dogs, or that's sort of the what's up for grabs here?
Yeah, I think that's for our listeners. We don't necessarily always talk about articles before we bring them on here, and so when John and I minds align, that's always a nice thing. Even though we try to bring up some contentious issues, perhaps like this. But you were saying this is about like maybe 5 or so years old thinking. That was the first thing that stood out to me. Actually, was that some of the arguments are a bit of a straw man, and they seem to harken back to this is what security looked like in the early 2000s or maybe early 2010. So I might flip my time machine switch a bit further to maybe 10 to 15 years older complaint about this is what security used to look like. And there's actually a reason we've moved on to DevOps and having security collaborate. And my focus here too, the thrust of what I would argue this is actually that application security can actually be an emergent property of DevOps done well. And what I mean by that is you have responsibility on the people who are building and operating the code, these services, products, etc., for security, and a security-minded team is helping them take on that responsibility in a way that has automation, in a way that they understand, in a way that works in their workflows. So that's why I think that there's this collaboration, is the sense no longer of security going in and saying, meet this checklist, or we have Doug and the auditor showing up. Make sure that you take this extra month to gather this evidence for our quarterly or annual review. It's more along the lines of, oh, hey, by the way, you have all these observability within your CI/CD pipeline. Can we just hook into that API that exists, or we're going to work with you to tweak that API to pull some real-time data back to make these auditors happy. And by the way, it also helps us have better confidence that we're building this software securely. So this is where, to me, it kind of misses the mark quite a bit, mostly due to this could have been true perhaps a decade ago, but I don't think it's true now, or it's at least true for those organizations that are struggling to move forward into how DevOps and security can and should, I think, play together.
Yeah, and I think I think he is building the straw man, and I'm not sure if he's doing it just sort of. I don't think he's doing it just for the sake of getting hits, but I think he's doing it to sort of stir a conversation himself, is my guess. If you look at some of his other posts, they're a little more modern and they're thinking a little more even keeled. I mean, hey, maybe he'd be a fun guest to bring on here, and we could yell at him for 30 minutes.
We could well, I'm trying to think of a good riff on that, but I'm not a yeller, as you'll notice, but I am trying to make sure we stay entertaining. The one other aspect I wanted to point on this too is that I think Zoom is actually a good example of their success getting ahead of their security. So Zoom just they once the pandemic hit, suddenly they had to deal with just the security issues of their installer and privilege escalation issues. So not necessarily, a remote code execution from that perspective initially, but security perhaps is a cost center, but security is very directly tied to can be tied to success of a product, as well as the being good stewards of data within a product. So I think I'm just going to use that as just another case of you can go and be successful without security, but you're going to need security to come in and collaborate with you. So I will still maintain that aspect very strongly, and just use Zoom as kind of an example of that. And possibly we've exhausted that topic, and maybe we should go on to the next one and talk about Rust. So Rust is showing up both in Android more directly and being talked about in the Linux kernel. So I'll take the Linux kernel aspect real quick, because one of the things that stood out to me is that with 30 million lines of code, you can't really expect or assume you're going to rewrite even 10% of that from C into Rust. Instead, they're talking about where's a good boundary, where's a good area where we could introduce Rust that makes sense. Both make sense from an engineering and security perspective, and going after like device drivers seems pretty smart to me, since they're relatively self-contained. They have pretty predictable boundaries. They're easy to separate these mental models of C code and Rust code. So looking forward to see that actually come to fruition. And there's an Android side of this as well. Don't know if there's something additional you wanted to mention on that aspect, John.
Well, it reminds me a little bit of what Taylor Swift has been up to recently when she's been re-recording a lot of her catalog. So she owns her recordings. It's in a way we're looking at re-recording a lot of the software which we've written in Android and Linux to make it more secure. I'm not going any further with that one. But really, across both of these, what does pop into my head is, if I was to think about mixing languages over the last, 10, 15 years of my career, I think the majority of the time I'd be thinking about that is if I wanted to bring in, if I had a performance area, I really needed to, really was performance sensitive on a particular piece of code. That's when you sort of switch over and get your 2 assembly guys to go and really crunch on that. As we're saying here, device drivers, right? So it looks now like the reasoning behind that has changed, and instead of just doing it purely for performance reasons, we're actually saying, hey, we can actually improve security by switching to a different language. And that train of thought is growing pretty quickly across the enterprise. And that to me is really interesting. I guess I'm trying to think of some other analogies off the top of my head. I've never, folks, if you're a really large development org, you might let separate teams play in languages of their choice. That doesn't happen too often because that's still just often these things don't play well together, right? So obviously the linker technology is getting a little bit better, I think, or at least we're getting more familiar with the options that have always been there. So it's interesting to watch from that point of view, and it'll be really interesting to see what this looks like, say, in another 12 to 18 months as these processes, as we start seeing the fruit from them, right? As we actually start, as an industry, rewriting a good chunk of this code and getting into a different language, that it'll be, hopefully, we'll be able to see sort of a visual drop-off in some of the vulnerability counts which are out there.
No, absolutely. I think this is a good chance for the Linux kernel to just look at C and shake it off. So missed opportunity there, John. Embrace the Taylor Swift plus the 1989 album.
Well done.
Good
Well
album.
done.
I will also say, so as you're describing, the shift to more memory-safe languages, this is a good trend. We've also seen, for example, shift in architectures, and we've covered some Chrome 0 days, some Chrome vulnerabilities in past episodes, as well as some design changes that Chrome, Firefox, for that matter, same thing with Safari, have been doing with process separation as well. So what's really neat is that we can improve memory management by adopting Rust, having our compilers help us out here. We can also improve protect ourselves by better process sandboxing. So even though we have all this legacy code that it's going to have that heap overflow, or it's going to have that off by one error on it, possibly with it, that's not going to necessarily give the attacker escalation into a protected memory space where where cookies are sitting or the sensitive information are sitting, because we've got process separation. Obviously, I'm hand waving a little bit, but just trying to highlight the combination of let's adopt some languages. There's still plenty of vulnerabilities out there that are not memory related. That's what I'm getting at. So there's still a reason to go for change in architectures as well. So
before we hop off that one, I think you brought up a really interesting way to think about it there, and that's we've suddenly sort of what we've been talking through here last few weeks, but particularly this last few minutes. There's this new hammer that's come into our box. Shiny hammer, has nice weight to it. We're used to using hammers. Now, okay, not everything's going to be a nail, hopefully. We're going to be a little more particular about it. But where do you use that hammer? So I think that what you're just sort of talking through is really the perfect thing. As an org is looking to improve their security stance, or looking to see how can we do that, right? Do we go and spend $50,000 on a WAF or a cloud WAF, or do we let a developer who's interested in Rust to pick out a section of code and maybe slowly but surely modify that and rewrite sections? That's something that's really interesting to think about as a manager, I think. So or as a whole team. So that's a good thought experiment for folks, I think.
Great point. Good thought experiment. So go out there. Let us know. We would actually love to hear how you've done that approach, because we talked with Leaf last episode about dropping security into engineering, and I'd love to hear what kind of language decisions have been made, or even architecture decisions have been made, and whether either successful or lessons learned, so we can learn from failures. Possibly learning from failures, let's hit a couple of articles that are sort of related on just vulnerabilities. So there There's one breaking GitHub private pages that turned into a bounty for $35,000. And I'm saying a lot, so I'm going to try to charge myself $35,000 for every that comes out unintentionally. But in this case, typically I kind of yawn at cross-site scripting. It's boring. It's been around for ages, as we talk about time machines and 5 to 10 to 15 to 30 years ago, probably by now. This case, one of the things that stood out to me is two things. It was a great write-up, so we always love to highlight a great write-up. In this case, it was a really neat thought process of the researcher saying, this is what I was looking at. Then I tried this. I saw CSRF. Then I saw that I couldn't get my payload in there. And the other part that really stood out to me was seeing a null byte inclusion. So a old school %00 or just a /00 escape sequence. And that bypassed a parser or bypassed the whatever filter was in place, and that popped the cross-site scripting. So really cool. Kudos to you for both getting a pretty nice bounty as well as a nice write-up for us to learn from.
The other thing which was really interesting
yes.
here on one more on this, which is really interesting. This is a 17, 18-year-old getting $35K. Nothing to sneeze at, right? So, over the years, one of the things which frequently people will ask me when we talk about any of these sort of security aspects, not so much the why did it care, but who's doing this, right? So back in the 90s and 2000s, I'd say, it was the angry teenager who was tired of playing games and he wanted to do something else and show off to his friends that he could deface a web page. Then we went through and we're still going through the APTs and the foreign either governments or organizations that are looking for either for just purely governmental reasons to make others look bad, or they're trying to get sensitive information, or all these different things. We've had a few threat hunters, researchers on the show that are usually, doing a pretty good amount of revenue off, or I should say, revenue off of HackerOne or some of these platforms. This is becoming another way, right? That who's coming after you and why. And this in this particular case is a great thing. But when folks think about, as you look through this write-up, right, it's not a simple. It's a pretty well done thing, and he is a pretty crafty dude to be able to figure this out, I think. And I'm thinking through just like some of the internal engineering conversations where you're figuring out, okay, we know we need to. I almost forgot. I'm going to back off for a second. We had a listener last week from down in Australia who took slight offense to our, particularly mine. I threw around the phrase authentication and OAuth. And I realize it's authentication versus authorization. So, we had that conversation on Twitter. Apologies. I will try to do better in the future. I think Mike's better at that than I am. But anyways, in this particular thing here, we're talking about authentication and how do we do it and it's being done right. And, you're probably thinking, I just have to either pass my penetration test or get our SOC 2, or who's actually going to go through and try to figure out cache poisoning on a particular URL. So, yeah, just long story short, it's there's always folks out there that are looking to sort of scratch that itch. So it's a pretty good example of this from that point of view.
Yeah, a great example. And also, for as much as I also stumble over words and say I'm a little too much, we're talking extemporaneously and trying to make sure we stay precise. So that's good that we do remain precise in our terms. And I'm going to use that as a segue, talking about just what you were saying about looking at pen testing. Who's going to think about cache poisoning? Who's going to look at this? Because, as I said, I try not to yawn all the time at cross-site scripting, but man, cross-site scripting is all over the place. We always see it. Just like we've always known that certificates are going to expire. That's one of the whole premises behind certificates. You get one and hold on to it, and once its expiration is gone, it's no longer supposed to be used. And yet, here is a postmortem from Epic Games, who was saying, oops, we had a wildcard TLS certificate unexpectedly expire. It's a little bit rough, we'll say, to say unexpectedly, since the expiration date is built into those certificates, but we'll be kind, because this was a case, again, where they're writing up a nice, transparent postmortem about what happened. And they were pointing out there was an expired cert. cause a problem between service-to-service calls, which is also a good callback to our last episode when we were talking about authentication and authorization between S2S calls. Thank you for that reminder, John. But then they were also pointing out unexpected traffic came up and an incorrect version of some artifacts being pushed out. So sort of this confluence events when why have one thing go bad when three things go bad at once? So again, it's this sort of that spirit of, on this case, this example, nothing earth-shattering or too exciting, but they still had that availability part of that CIA triad caused problems. So known engineering problems with relatively known engineering solutions, but still mistakes are being made, as I will use the passive sentence there. But this was still a good write-up. We love to see this type of transparency, and let's have some more of that.
Yeah, definitely. So the write-up's great, probably a little more focused on the operational folks that are, suddenly we're seeing a spike in our traffic. Why? Two things here. One, for the developers, perfect example of why you don't throw away errors, particularly in Go, right? People have a habit of underscore equals and just ignore that error. There's, if that error was saying, hey, we couldn't actually make that TLS connection, and you could have logged that, and the ops guy could have seen, oh, crap, certificate expired. You could have saved a hell of a lot of work right there. So please don't throw out errors. And I'm doing as much as you are, I think, today. The second one in here is the second one was, I think I've talked about this briefly in the past. Certificates on something like a Kubernetes cluster, if those expire and you have to replace them, man, you're in for just a wonderful afternoon. I'm telling you, it's just don't pass go, throw the thing out, rebuild the whole cluster. I mean, you can do it. You can go through and replace that cert across your kubelets and your etcd and all those components. There's blog posts out there on how to do it, but it's just one of those examples of, long story short, set up monitoring on these things and know when they're going to expire. Worst case, if you don't have monitoring, put on your calendar. It sounds like, a year from now we'll get to it. Before then, trust me, this will bite you.
Yeah, put it on. And another trick, so this is just a simple operational trick. You can always control the expiration date. Try to make the expiration date fall on something like a Tuesday through Thursday during your normal business working hours. Try to avoid having it fall on a holiday, fall on a weekend. These are just small things that, yes, you should have automation that handles this seamlessly, handles this automatically. But when you do find those problems and you forget about those errors because your op folks missed something, it's great to have it happen when you're not on call in the middle of the night. So just small tricks there. And let's see. So also speaking of nuke it from orbit and your Kubernetes and your certs, here was a codecov.io. There is, I mentioned this in our discussion with Doug, already forgetting who our guest was. Look at that. And you alluded to this a little bit there, John, when you're talking about the integrity of the build process, what's happening at each step. In this case, developers love doing testing. They love looking at code coverage of what has been tested. In this case, what stood out to me for codecov.io, on April 1st, they said, we found that one of our basically bash scripts, bash uploader, was backdoored and leaking data that it shouldn't be leaked. And it has been the case for about 3 months. And so this is something that is always of concern, and gets back to just what you were talking about monitoring by your ops folks, is if this was introduced and existed for 3 months, both missed by codecov.io, and hopefully I keep repeating the name of their site correctly, as well as all of the users of that's something to be said of, what should we go back and look at this and say, should we have had better network security monitoring? Should we have something else that should have highlighted that, or egress rules, so that a compromised account is only ever talking to the right API and not some other unexpected API? So I think another good lesson learned that you could also just use as a pre-mortem, even if it didn't affect you, in the sense of, well, what if it did happen to us? Do we have controls in place that would have at least helped us detect or prevent that type of problem, to use that NIST cybersecurity framework language?
This, yeah. It's funny. I don't think I'd thought too much about that question I asked Doug earlier, but this is, the more I think about it, I think this is sort of the core of the issue. It's not so much do we have a secure lifecycle setup or all these sort of things we're talking about in code signing. How much trouble have we actually gone into to actually doing some things you've just talked about, setting up that build process correctly, making sure that it's firewalled off appropriately, preferably air-gapped, but let's get back to reality. And then actually thinking through the tools which we got going just for the sake of getting them going so we could go back to writing the code. Did we pick best options? Did we actually look at the security docs for those tools? Did we go through actually how to use them correctly? I feel not very strong about that for many instances out there. So that's something to think about and meditate on a little bit on a happy Monday afternoon.
All Monday afternoons are happy, John. There is another segue now. I'm going to loop back a little bit to that Epic Games certificate expiration and talk about BootHole real quick. So Eclipsium came back with just 9 months later, how it started, how it's going. Always a fun meme with BootHole. This is a reference back to Grub bootloaders and the root of trust, which is essentially a pretty important aspect of modern computing in the sense of, especially in the sense of supply chain, meaning my device, my system, my cloud instance is booting up. How do I trust, and how well can I trust? How much confidence do I have, and other synonyms, for the software that's running on it, from the firmware that launched it, to the operating system, to the device drivers, to everything else, to the code that I've written in the third-party libraries I've pulled in. So long story short, or that was the long-winded way to describe the follow-up to BootHole. And one of the things that stood out to me that was just kind of interesting is that just as we were talking about Epic Games and certificate revocation, certificate expiration, this case with BootHole, they actually had to go and revoke a whole bunch of certificates because they had been exposed, compromised. And they also had to release well over 100 different patches to this ecosystem of the bootloaders. And one of the interesting aspects, they also said, we work in a constrained environment. We can't have a super long list of certificate revocations. And just in responding to BootHole was they hit 50% capacity of what their database can handle for revocations. So that kind of implies that one more bad BootHole, they're at 100%, and they have no more memory to track what should be revoked. Bad situation. So I threw a link in here to what they called Secure Boot, or their SABT, that I just forgot what it stood for. But a neat write-up, and it's just a nice thought process to say, here is a problem. We want to be able to revoke certs or revoke firmware or revoke images. How do we track that in a nice, consistent manner, and in a low memory environment as well? So kind of a neat write-up. Cool. It goes into the category for me of, this is some neat engineering. I might not be able to directly learn from it, but I can appreciate the thought process and perhaps reuse that in some other case when something similar comes up.
Yeah, it's. I don't have too much to add. It's a little. I missed that part you just said about they're running out of space for the CRLs. That's sort of mind blowing. Any modern chip that I can think of has plenty of space on there for that. So I know they're probably working on some of the smaller, little older chips that don't have quite as much space for that. But that's still sort of mind blowing that one particular class of issue, it could make the future security of that device questionable, as to how I'd phrase that.
Yeah, the other thing, if you have any mind left, the other part that might blow it is they also mentioned, we're going to start putting stack protection onto this area of code too, which is a little bit, a bit late to the game, but glad they're at least addressing that now. So always good to take advantage of a crisis. So there is now the one, at least, maybe not the last, but one more article that I was saving closer to for the end because I think we'll have some fun talking about it if we've got some time left. This is Project Zero, this adjusting their policy and disclosure for 2021 for vulnerabilities. And this is a case, in general, I kind of think of the whole area of vulnerability disclosure policies as it's sort of the trolley problem of the InfoSec world, where you have some relatively some examples of dilemmas with relatively contrived constraints, and it's just sort of a teaching moment. Do you make this decision or this other decision? And I like to just pull back a little bit and look at the transparency of how they wrote this up, what their thought process was, and that they're saying we're going to add an extra basically sub 30 days to appreciate the time it takes for users to patch, meaning that they acknowledge that there are users as part of this ecosystem of security who probably don't have the sophistication to understand how much, how exploitable is this heap overflow, or do I need to chain some of these vulnerabilities together to get a proper RCE, or can I turn this DOS into an RCE? They just more of, oh, oops, what version of Chrome should I be on? Or I just need a few more days for my auto update to kick in and, update my iOS or update my Android, etc. So I do like that they're acknowledging the aspect of patching time in here. And the other thing I just wanted to throw in, I threw in some show notes, a little bit of the history of the vulnerability disclosure discourse over the past decade at least, if not longer, going back to the RFP, Rainforest Puppy, and his full disclosure vulnerability text file that he put out, as well as a lot of Katie Masuras's work that was very seminal to this field when she was at Microsoft Security Research Center, and the work that she's done on the ISO standard for vulnerability disclosure processes or vulnerability reporting, as well as I want to throw out there too, it's one of the very few ISO standards that are in fact freely downloadable, freely available, and that was due to her work. So some interesting aspects here, just sort of that meta conversation about vulnerability disclosure that I wanted to step into. So speaking of stepping into things, John, what would you like to put your foot in on this topic?
It always rubbed me the wrong way, the 30-day window that Project Zero had, because they were really, at least to me, it seemed like they were very, I'll say, grating on how they would actually do that release. It seemed like they were, it was very much a, we're Google, we know how this should be done. Anyone should be able to patch this within this number of days. Obviously, we know better than you. We've given you the time. We're off to the press. It's a tight window. And I think in some cases they were getting a little more flexible anyway. So I'm glad to see they've done this. It's just look at that last article we were talking about. Not patching, but all the issues we've seen off secure boot or off the grub vulnerability. And there's something else crossed my mind in the last few weeks, like just even if that announcement for some of these very critical issues goes out, along with patches and everything, and we should all be patched and that type of thing, months and months later, we're still seeing issues. So if we can at least give the people who are trying to be cognizant and trying to stay on top of these things, give them a little more time to catch up on that before you go and announce to the world, I think that's going to be very appreciated by everybody.
Yeah, I think that gets to the idea of the term of art I like is the coordinated vulnerability disclosure. And if there is coordination from good faith between good faith actors, why not? Let's work things through. Let's have some deadlines, because as with anything, it's good to have who's responsible and when should this be done by. That's just, I think it's going to be basic engineering 101, basic business 101, as you're sitting in your meetings looking at what tasks there are for the week, for the month, for the quarter, et cetera. Those are good aspects. So kudos, I think, for having this discussion out in the open, as well as having that flexibility to look back and say they made some changes in 2020, a few tweaks. They did some changes here in 2021. And assuming we're all still around in 2022, considering how horrible things have been going, Who knows what changes they'll see then? But I think we'll see just some more tweaks as they respond to the whole patching and as well as research ecosystem around vulnerabilities being disclosed. And I think that is going to bring us to the end of our episode. So, no bad blood for the Taylor Swift fans out there. You've got me on your side at the very least, and John had some nods in there as well. And as well for you Twilight Zone fans, whether the monsters are due on Maple Street or you're looking for space in the shelter, thank you for joining Two Characters in Search of an Exit. We'll see you next week on Application Security Weekly.